No, oh, okay. Okay, let's get started. So the first rule that we have learned, if you have, logarithm x and y together, this one, let me remind you, this one is kind of multiplying, right? And we have learned in the last session, if we have, multiplying, we need to turn it into addition, right? What I want to do is just try to write a double log, and remember, in the middle, this one is kind of addition, right? Because I told you the last time the multiplying, it must be turned into addition, right? And what I want to do is just try to keep the same base. The base is 2. So let me try to write it. A couple 2, right?
Yes.
And this one is kind of distribution. So it's going to be x and y. Did you get it?
Mm-hmm.
But I'm just thinking, what if we have the inverse? What if you have the inverse? Let me show you how. If you have logarithm a and to the base of 5, and we have logarithm b to the base of 5 as well. So this one is kind of, we have the inverse, which makes sense. I have to do the, I have to do the inverse. As I told you, if you have multiplying, we need to turn it into addition. And what if we have addition? What if you have addition?
If we have addition, it's gonna be.
We need to turn it into multiplying, right? So I have to keep the same base. The base sounds like 5. And what I want to do is just try to multiply a and b together. Did you get it?
Yes.
So this is the first rule that we have learned the last time. Let me remind you about the other rule. So the other rule, it sounds like if we have logarithm, and here we have, for example, x, and what we have right over there, a over b. The last time I told you, if you have, dividing, we need to turn it into subtraction, right? So the first step I have to do is just try to write a double log, but in the middle we get subtraction, not addition this time. Did you get it? So what I want to do is just try to keep the same base, and here we have a, on the other side we get b. Did you get it?
Mm-hmm. Yes.
Okay, and sometimes probably that we have the inverse, which makes sense if we have right over there logarithm a, and here we have, for example, 15, and here we have logarithm a, and here we have 5. This one is kind of subtraction, right? If you have subtraction, what I want to do is just try to turn it into dividing, right? So I have to write over there log. So just try to keep the same base. What is the base? Sounds like a, right? And then it's going to be 15 divided by 5. Is this one clear for you?
Yes.
Okay. The last thing that we have learned in the last session, let me remind you, even if we have something that sounds like a logarithm 5, and here we have x to the power of 2. What the first thing, I think you have noticed that we got power right over there, right? The last time I told you that we need to kick it out, so it sounds like coefficient. So I could write 2 logarithm, the base is 5, and here we have x, right?
Yes.
Is this one clear for you?
Yes.
I was trying to remind you about everything I'm saying that we have learned. This one, we need to, this time, in our session today, we need to move to, just a little bit farther to something else. Sounds like an equation. You know, the equation, it comes off the left-hand side or right-hand side, but probably you have noticed that we get the same logarithm and we get the same base, right? And this one is kind of, addition, right?
Mm-hmm.
So what should I do?
So addition is it's gonna be multiplication, right?
Yeah, right. So as I told you that addition, yeah, you're right. Sounds like correct. You could write it just like we get the same thing, logarithm, right? And this one is gonna be x. So then multiplied by x minus 3, right?
Yes. So log x minus 3. Okay.
Did you get it?
So it's gonna be x times x minus 3.
Okay, which equals to 2, right? And I kept it the same base. I kept it the same pace. So what I want to do, just to try to distribute x all over every single term inside the parentheses, which makes sense. I have the same thing, log of rest. Here we have 2, and x times x, which is supposed to be x squared, minus 3x, which equals to 2, right? Let me remind you something that helps you to understand what I mean. The last time we have learned it, how could it turn from exponential equation to logarithm equation, right? So if we have 2 to the power of x, which equals to 8. The last time I told you we need to learn very well how could it turn from form to another. This one's been written exponential function, exponential equation. And right now I need to turn it into a logarithm equation because it helps me to get the power, if the power is variable.
Is it gonna be log 2 raised to the power of 8?
Yeah, and what I want to do is just to try to turn it. So this one's called base, and this one's called the power. Base, this one's base, this one's power, and this one's result. So right now I need to write their places. So 8 right over there and x right over there. And right now you could use your calculator to get it. But what if we have this form? I need to turn it into exponential. How could I do it? So the first thing I have to do, I'm looking for the base. Where is the base? The base, it sounds like 2, right? So let me try to keep 2. So 2 to the power of x, which equals to 8, right?
Yes.
Did you get it? So right over there, I have to do the same thing. I have to turn it from being written into logarithm equation into exponential equation, right? Did you get it? So how could I do it? I'm looking for the base firstly. Where is the base? Where is the base? To the power of 2, which equals to x squared minus 3. Did you get that?
Yes.
So what is 2 squared? 2 squared is 4, right? Oh, I made a mistake. This one's 3x. My bad. So this one's going to be x squared minus 3x, right? Did you get it?
Yes, I got it.
Okay. What I want to do is I just trying to combine all of them in the same side, which makes sense. I need to move 4 to the other side. And remember, when you try to move something from the left-hand side and right hand to the right-hand side, or the vice versa, we need to use the inverse sign. So if it was positive, I need to turn it into negative and vice versa. And this one sounds like positive 4, which makes sense. It's going to be negative 4. So you could write it just like x squared minus 3x and negative 4 equals to 0, right?
The 2 raised to the power 2 was 4.
Yeah, 2 to the power of 2, it's 4. 2 times 2 is 4, right?
And then we still keep it outside, and then x squared minus 3x. Why is the 4 on the other side?
Yeah, because 2 to the power of 2 is 4, right? So I brought it down, and then I'm just thinking to combine all of them together in the same side, which makes sense. It's going to be x squared minus 3x.
Okay, and then everything is equal to 0. Okay.
Yeah, because this one sounds like a quadratic equation, which makes sense. I need to solve it. And every single time we are dealing with the quadratic equation, I need you to remember that we get a couple solution, because this one sounds like we have a parabola, which makes sense. This one cuts, into 2 points.
And that
points of intersection.
At 0?
Yeah, so the points of intersection between the parabola and x-axis sounds like 2, right? Which makes sense. Okay. What I have to do is just try to open up 2 brackets. The first one is x and x. What about 4? I'm just thinking what is the sign of the last term? The sign of the last term, it sounds like negative, which makes sense. I'm looking for two number. The difference between them is 3, right? So we have 1 times 4, because this one, I'm looking for the product of 4. So we have 1 times 4 and 2 times 2. Let me try to cancel it out, because this one, it doesn't work with us, because the difference between them is 0, not 3, right? But probably
Mister, do we have to find the x here?
Yeah, I need to find out
Should I
x.
replace it with something else?
Yeah, but you know, at the beginning of the question or head of question, he asked me to find out x, right? Which makes sense. This one sounds like quadratic. You could use your calculator to find out what x stands for, but I'm trying to do it with the steps to show you how could I find out x. Did you get it? So I can do it again. So listen, probably you have forgotten, but let me remind you. Okay, wait, hold on. The first thing, I need to investigate the sign of the last term. What is the sign of the last term? Because the sign of the last term is really important. The sign of the last term, it sounds like negative, right? Which makes sense. I told you that the last time is the sign of the last term is negative. So I'm looking for two numbers or two factors, the difference between them in the middle. The middle, it sounds like 3x. So I'm looking for two number. I mean, the product of 4 or the factors of 4, and the difference between them, it must be 3. So definitely we have 1 times 4, and we have 2 times 2. The reason why did I cancel 2 times 2? Because this one, it doesn't work. Because the difference between them is 0, and I'm looking for two factors. The difference between them is 3, right? So I'm looking for 1 and 4. And what I want to do is just try to open up two brackets. It's going to be x and x. And here we have 4 and 1. And definitely this, the greatest one of them takes the same sign of the middle. And definitely the greatest one sounds like 4. So 4 takes the same sign of the middle. So the sign of the middle is negative. So this one's going to be negative and this one's going to be positive, right? But I haven't done it yet because I need to equilibrate every single bracket with 0. So it's going to be x minus 4 equals to 0. On the other side, we get x plus 1 equals to 0, right?
Mm-hmm.
And then I need to isolate x by itself, which makes sense. I need to move negative 4 from being on the left-hand side to the right-hand side. So x equals to 4. On the other side, x equals to negative 1, right? Which makes sense. I have a couple of solutions. Did you get it?
Mm-hmm.
Is this one clear for you?
Yes.
So it seems like pretty simple, but we need to understand how could I deal with the logarithm and the rule which I was trying to teach you the last time are really important, and you need to recall it. Did you get it?
Okay.
Okay. This time, I need to give you another example. This example is really important. But I need you to end up the meeting and try to rejoin, okay? From the same link.
Okay.